For years, scientists around the globe have debated what exactly Oumuamua is. When it first entered our solar system in 2017, it defied every known model. Was it an asteroid? A comet? Or could it be something much more mysterious, something artificial? That debate went silent after Oumuamua exited our solar system just as quickly and mysteriously as it arrived. But now, in 2025, it has returned. And it's not traveling solo. NASA has confirmed the presence of multiple unknown objects accompanying Oumuamua as it re-enters our cosmic neighborhood. This revelation has left astronomers stunned and theories running wild. From alien technology to a previously unknown class of interstellar objects, the implications are staggering. Could these mysterious companions be evidence of intelligent life? Or are they part of a natural phenomenon we've never witnessed before? The space community is in a frenzy. New data from NASA, the European Space Agency, and private observatories is pouring in. What's clear is that something unprecedented is happening. We are witnessing the return of the most controversial space object of our time, this time with backup. As public interest skyrockets, searches for terms like Oumuamua returns 2025, NASA confirms alien object, and mystery in space are trending across the internet. Scientists and civilians alike are asking the same question: why now, and what does it mean for us? This isn't science fiction. This is unfolding in real time. And if what the experts are hinting at is true, we may be on the brink of the greatest discovery in human history. Stay with us as we unravel what might just be the biggest space mystery of our lifetime. What is Oumuamua? Back in October of 2017, a telescope perched atop Hawaii's Haleakala volcano picked up something strange hurtling through our solar system. It was fast, faster than any known asteroid or comet ever detected. At first glance, it looked like an unusually long and slender rock. But this was no ordinary space rock. This was Oumuamua, a name that means a messenger from afar arriving first in Hawaiian. And it would go on to become one of the most baffling mysteries in modern astronomy. Oumuamua was officially recorded as the first known interstellar object to visit our solar system. That term, interstellar object, refers to something that originated outside our solar neighborhood, likely ejected from another star system billions of years ago. But from the moment Oumuamua was spotted, nothing about it added up. It was traveling at a blistering speed of about 315,000 kilometers per hour, moving on a hyperbolic trajectory, meaning it wasn't bound to the sun and would eventually exit our solar system altogether. Its shape added more confusion to the puzzle. Based on its light curve, the way its brightness fluctuated as it rotated, scientists deduced that Oumuamua had an elongated, cigar-like shape, possibly 10 times longer than it was wide. No naturally occurring object in our solar system had ever been observed with that geometry. This odd shape alone had some experts scratching their heads. But the real kicker came when astronomers noticed something even more unexplainable. As Oumuamua drifted past the sun, it began to accelerate. Not due to gravitational slingshot effects or planetary influences, this acceleration appeared to be non-gravitational. Typically, this sort of behavior is seen in comets when sunlight heats up their icy cores, causing gas to vent out and push them along like cosmic rocket engines. But no such gas or debris trail was detected behind Oumuamua. It was accelerating, without an engine, without a visible force. This contradiction led to a flurry of theories. Was it a new type of comet, made of hydrogen ice or nitrogen that evaporates invisibly? Was it a fragment of a disintegrated planet or moon from another star system? Or was it something even more provocative? Harvard astronomer Avi Loeb introduced the most controversial idea of all. What if Oumuamua wasn't natural? What if it was an alien probe, an object sent intentionally by another civilization to explore distant star systems, including our own? His argument wasn't made on fantasy, but on data. He pointed out that the acceleration, the shape, and the complete lack of a gas trail all made more sense under the artificial object hypothesis than any known natural explanation. Not everyone agreed. In fact, many scientists pushed back against the alien probe theory, citing that extraordinary claims require extraordinary evidence. Yet, none of the conventional theories fully explained Oumuamua's behavior either. It simply didn't fit into any known category of asteroid, comet, or space debris. It remained an enigma. By early 2018, Oumuamua had passed out of range, becoming too faint for telescopes to track. The mystery faded from headlines, but not from scientific discussion. It remained a case study, a riddle carved into interstellar stone. Its brief visit left more questions than answers, forcing the scientific community to rethink everything it thought it knew about what's flying through the cosmos. So when news broke that Oumuamua had returned, this time with mysterious companions, those old questions resurfaced with new urgency. Was the original encounter a one-time cosmic accident, or was it the first chapter of a much larger story unfolding in the depths of space? Whatever Oumuamua is, one thing is clear: we're not done with it yet. The return of Oumuamua, what we know now. In early 2025, a team of astronomers at the Cerro Paranal Observatory in Chile detected something strange moving through the night sky. What initially appeared to be a fast-moving object, possibly another interstellar interloper, soon revealed a more startling truth. As more observatories locked onto the target and data was shared globally, it became clear that this object was familiar. It matched the trajectory, velocity, and some of the unique light curve characteristics of a visitor from 2017. Oumuamua had returned. The news broke quietly at first, with small mentions in academic circles and astronomers' forums. But the confirmation didn't take long. NASA issued an official statement confirming that the newly observed object was indeed consistent with the return path of the first known interstellar object. Except, this time, there was a twist. Oumuamua was not traveling alone. The object re-entered our solar system from the opposite side of the Sun, this time approaching at a slightly altered angle. That alone raised eyebrows, because interstellar objects typically don't return. They're not like comets that orbit the sun. Once they pass through, they're gone forever, flung into deep space by gravity and momentum. The very concept of an interstellar object like Oumuamua making a return pass defied astrophysical expectations. And yet, here it was, unmistakably back in our sky. Scientists were quick to note that Oumuamua's physical signature had changed. While it retained its erratic tumbling motion, its light curve showed slight inconsistencies when compared with 2017 data. The reflectivity appeared to have shifted in a way that suggests either material changes on its surface or interference from nearby objects. These nearby objects are at the heart of the mystery. Accompanying Oumuamua were several smaller but similarly fast-moving bodies, traveling in formation, or at least close proximity. That detail sent ripples through the astronomical community. Initial reports from NASA indicated that 5 additional objects were moving with it, each measuring between 30 and 70 meters in length. Unlike traditional meteor showers or comet fragments, these objects didn't seem to be trailing debris or showing signs of disintegration. They were moving with Oumuamua at high speed, maintaining consistent distance and velocity patterns. The formation was not random. That's what troubled scientists most. The European Space Agency released its own findings within days of NASA's announcement, noting that the grouping's flight path resembled a calculated trajectory. Not chaotic, not incidental, but precise. The idea that these objects might be gravitationally bound was ruled out quickly. They were too far apart and moving too uniformly to be affected by Oumuamua's limited mass. This suggested coordination, or at the very least, a shared origin. This data forced astronomers to re-evaluate previous assumptions. The theory that Oumuamua was a chunk of natural debris lost some of its weight. After all, how many pieces of rock return years later with companions, at hyperbolic speeds, without any gravitational assistance? And how many change their reflective profile while doing so? As observatories across the globe pointed their instruments skyward, new questions emerged. Could the initial 2017 pass have been a reconnaissance flyby? Was the return pre-programmed? Or is there an entirely new class of interstellar objects that we've just begun to discover, behaving in ways we've never imagined? NASA's most recent announcement, released just weeks after the confirmation of Oumuamua's return, stated that the agency is dedicating increased telescope time and computing resources to analyzing the object and its companions. High-resolution spectral analysis is underway, looking for chemical traces, structural anomalies, and any sign of artificial material. Meanwhile, private space research firms and academic institutions have joined the race to decode the return. Machine learning models are being trained to detect patterns in the object's movement, while SETI researchers are quietly listening for any radio signals that might hint at something more intentional. This time, the world isn't letting Oumuamua slip away without answers. In 2017, we were unprepared. Caught off guard. Now, in 2025, we have better tools, faster processing, and a far more urgent curiosity. The re-entry of this object, and its entourage, has reignited global speculation. The phrase, Oumuamua returns, is trending, not just in astronomy circles but across social media, search engines, and news outlets. Oumuamua 2025 has become a top keyword on YouTube and Google. Every new piece of data brings us closer to understanding what this truly is. A natural marvel, an unprecedented cosmic anomaly, or perhaps something far beyond anything we've encountered before. One thing is certain, Oumuamua's return is not a repeat performance. It's the next chapter in a mystery that could redefine our understanding of the universe. It's not alone. The mysterious companion, the objects traveling with Oumuamua, are unlike anything we've seen before. When news broke that Oumuamua had returned to our solar system, the scientific community braced for another wave of questions. But few expected the twist that followed. Oumuamua was not alone this time. Accompanying the interstellar object were several others, each moving in tandem, each matching its velocity, and none behaving like anything astronomers had ever observed before. Suddenly, Oumuamua was no longer just a mysterious visitor. It had become the front of what some are now calling an interstellar convoy. The details surrounding these companion objects are still emerging, but what has been confirmed is already shaking the foundations of what we thought we knew about space travel, natural celestial bodies, and even the possibility of artificial intelligence beyond Earth. Telescopic observations from NASA, the European Space Agency, and multiple international observatories have locked onto at least 5 distinct objects accompanying Oumuamua. Each object appears to be elongated in form, just like Oumuamua, and ranges in length from 30 to 70 meters. Initial speculation assumed they were fragments, perhaps pieces of a larger parent body that had broken apart. But that theory was quickly dismissed. These objects are not tumbling uncontrollably as fragments typically do. Their rotations appear stable. More importantly, their movements are synchronized. They are keeping pace with Oumuamua not just in speed but in directional vector and formation spacing. That's not how natural space debris behaves. It's how a formation of aircraft flies. It's how a convoy moves. The term, interstellar convoy, might sound like something out of science fiction, but it's now appearing in published scientific papers and official NASA briefings. What makes this so extraordinary is the precision. These objects are not just clustered loosely near each other. They're maintaining consistent distances over long observational periods, resisting the gravitational tug of nearby planets and solar radiation effects that should otherwise scatter or separate them. High-resolution imagery and deep space tracking models show that the formation isn't static. It adapts. As Oumuamua adjusts its path, often with minute, seemingly intelligent course corrections, the companion objects adjust accordingly. It's as if they are responding in real time, not merely following gravitational momentum. This led NASA scientists to use language rarely seen in public-facing documents. In one of the more sobering updates, a senior astrophysicist at NASA's Jet Propulsion Laboratory described the movement as anomalous and non-natural behavior. Those words, anomalous and non-natural, have sparked a wildfire of speculation. To many within the scientific establishment, they're cautious phrases used when the data doesn't fit known models. But to the broader public and even some fringe researchers, they're being interpreted as something more. The phrase, "Oumuamua not alone," is now flooding search engines, trending on platforms like YouTube and Reddit, and capturing the imagination of millions. Could this be evidence of an alien fleet? That's the question nobody wants to ask on the record, but many are thinking about privately. Harvard's Avi Loeb, who previously suggested Oumuamua might be artificial, has once again stepped into the conversation. In a recent interview, Loeb stated that the presence of companion objects increases the likelihood that we're dealing with engineered technology rather than natural formations. He emphasized that in nature, such coordinated behavior on this scale is virtually unheard of, especially across vast interstellar distances. Complicating matters further is the behavior of the objects themselves. They're not emitting any detectable gases, nor are they leaving behind the dust trails typical of comets. Radio telescopes have not picked up any transmissions, but SETI researchers have ramped up efforts to scan a wider frequency range. Even in silence, these objects are speaking volumes. Their sheer defiance of natural orbital dynamics points to something we can't yet explain. If we entertain the possibility of an artificial origin, the implications are staggering. Are these probes scouts? Autonomous drones? Could Oumuamua be a command vessel, with the others acting as sentries or collectors of data? This idea may sound extreme, but it's grounded in the very patterns we see emerging. Even NASA, traditionally conservative in public assessments, has not dismissed the alien fleet theory outright. Instead, they've labeled the event as worthy of extraordinary scrutiny, which, in scientific terms, is a huge departure from standard language. As data continues to stream in, simulation models are being developed to predict where the objects are going. Thus far, they've made several slight course corrections, suggesting an intelligent response to gravitational fields or observational satellites. That behavior is making astronomers uneasy. Not because they fear a threat, but because the pattern suggests a level of awareness, something that inanimate objects shouldn't possess. One possibility is that we are witnessing a form of self-guided navigation never before seen in interstellar phenomena. Another theory gaining traction is that these objects may be part of a relay system, communicating among themselves or with a distant point beyond our reach. Their spacing and formation could be optimized for maximum sensory coverage or transmission clarity, just as we deploy constellations of satellites in Earth's orbit. At the same time, skeptics caution against jumping to conclusions. Some astrophysicists suggest we may be witnessing a unique natural phenomenon, perhaps a cluster of icy bodies reacting to unknown solar influences or a never-before-seen interstellar mechanism. But even these voices admit they're stretching the limits of conventional astrophysics to explain what's unfolding. Whether natural or artificial, benign or exploratory, the one certainty is that we are facing an unprecedented situation. Oumuamua is not alone. And whatever these companion objects are, they've just rewritten the rulebook on what's possible in the vast, uncharted expanse of space. The next weeks and months will be critical. As observatories worldwide continue to monitor the object's movements, every change in trajectory, every anomaly in signal, every nuance in light reflection will be analyzed to the finest detail. The answers may still be far away, but the questions are clearer than ever. The era of dismissing these mysteries as mere coincidences is over. Oumuamua has returned. And it has brought a fleet. Scientific theories versus conspiracy theories. What the evidence really tells us about Oumuamua's true nature. Since its first appearance in 2017, Oumuamua has been a magnet for both scientific inquiry and speculative fantasy. Its return in 2025, accompanied by multiple anomalous objects, has only fueled an already fiery debate. As NASA, SETI, and international observatories continue analyzing the unusual behavior of this interstellar visitor and its mysterious companions, the world finds itself caught between cold scientific logic and a rising tide of public speculation. In this climate, understanding where the initial theories proposed after Oumuamua's 2017 flyby ranged from cautious to creative. Scientists were quick to classify it as a comet, until it showed no cometary activity. Then it was labeled as an asteroid, until it inexplicably accelerated. A few hypotheses emerged attempting to account for these contradictions, each one grounded in physics but pushed to the edge of credibility. One such model proposed that Oumuamua was a fragment of a nitrogen iceberg, possibly originating from a Pluto-like exoplanet that experienced a cosmic collision. In this theory, the nitrogen surface would sublimate as it approached the Sun, creating a gentle thrust capable of altering the object's trajectory without leaving visible gas trails. While plausible, this scenario hinges on several improbable conditions, including the existence of such nitrogen-rich bodies in large enough quantities to produce debris capable of interstellar travel. Another explanation centered on the idea of hydrogen ice. According to this model, Oumuamua could be made entirely of solid hydrogen, a substance that would also sublimate without detection. However, critics quickly pointed out that hydrogen ice is unstable and unlikely to survive the journey through interstellar space without disintegrating. Moreover, no such hydrogen icebergs have ever been observed, making this theory more speculative than its proponents initially admitted. Then came the solar sail theory. This model posits that Oumuamua might be a thin, reflective structure propelled by radiation pressure from stars. In other words, an artificial sail designed for space travel, just like the concepts being developed by humans today. The idea gained traction not because it sounded exotic, but because it provided a consistent explanation for the object's unusual acceleration. It didn't require gas or gravity, it just needed sunlight. This was the moment Harvard professor Avi Loeb stepped into the global spotlight. Loeb, a well-respected astrophysicist and head of the Galileo project, publicly suggested that Oumuamua might be of artificial origin. He proposed that it could be a discarded piece of alien technology, a probe or light sail designed to explore other star systems. His argument rested not on wild imagination, but on the principle of parsimony. If no natural explanation fits all the data, perhaps an artificial one should be considered. Loeb's claims sparked controversy across the scientific community. Some accused him of sensationalism, arguing that introducing the idea of alien technology too early risks damaging public trust in science. Others praised his courage, suggesting that the scientific process should be open to all possibilities, however uncomfortable. His published book, Extraterrestrial, The First Sign of Intelligent Life Beyond Earth, became a bestseller, and his name remains closely tied to Oumuamua in both scientific literature and online discourse. As the object returned in 2025, the alien probe theory returned with it, this time with renewed urgency. The presence of companion objects lent additional weight to the idea that Oumuamua might not be natural. Once again, Loeb emphasized the importance of analyzing all available data without dismissing the artificial hypothesis out of hand. And this time, the public seemed more willing to listen. Online platforms exploded with speculation. Social media feeds filled with hashtags like #OumuamuaFleet and #AlienProbe2025. Viral videos racked up millions of views, many of them making claims that went far beyond what the data could support. Some users suggested the objects were part of a reconnaissance mission from a Type II civilization. Others believed it was a slow-motion invasion or a long-forgotten alien relic that had finally come home. Forums discussed everything from reverse engineering alien tech to spiritual awakenings triggered by the object's return. This wave of attention wasn't limited to casual stargazers. Influencers, tech leaders, and even politicians began chiming in. Public pressure mounted for more transparency from space agencies. NASA found itself balancing the need for scientific rigor with the reality of an increasingly conspiratorial internet. In response, it released multiple technical briefings, emphasizing the complexity of the object and the importance of data-driven conclusions. So what does the data actually tell us? Based on current observations, Oumuamua and its companions exhibit behaviors that resist natural classification. Their speed, formation, lack of expected emissions, and mid-course corrections are not easily explained by known physics. However, this does not constitute proof of alien origin. It merely confirms that the objects are, for now, anomalies, outliers in a universe full of mystery. Some scientific voices caution that we're experiencing a form of cosmic pareidolia, the human tendency to find patterns and intent where none exist. Others argue that dismissing the alien hypothesis outright is just as unscientific as accepting it blindly. The truth may lie somewhere in between, buried in the terabytes of telescope data now being processed across the globe. To help separate fact from fantasy, institutions like the Galileo Project have begun publishing open-source analysis, allowing researchers and independent experts to review raw data and apply their own models. Artificial intelligence is being used to simulate trajectory adjustments, surface material properties, and even possible communication signals. Thus far, no one has identified conclusive evidence of artificial origin, but no one has been able to disprove it either. As for conspiracy theories, many are rooted in legitimate curiosity. But some have taken a darker turn. Claims of government cover-ups, secret space programs, and imminent alien contact have emerged from the online echo chamber, often supported by doctored images or pseudo-scientific jargon. While it's easy to dismiss these ideas as fringe, they reveal a deeper truth about the human psyche. We want to believe we're not alone. And when reality offers us a mystery as compelling as Oumuamua, imagination rushes in to fill the gaps. The debate over Oumuamua reflects a larger tension in modern science, the push and pull between cautious skepticism and boundless curiosity. As data becomes more available and observation tools grow more advanced, we may one day solve the mystery of this strange traveler. Until then, the conversation continues. For now, Oumuamua remains suspended between worlds, not just between stars, but between explanations. It is both a scientific challenge and a cultural mirror, reflecting our hopes, our fears, and our deep need to understand the unknown. Whether it's a fragment of cosmic ice, a sail from a distant civilization, or something we've yet to imagine, one fact is undeniable. It has changed us. And it may change everything we think we know about our place in the universe. What the data tells us, statistics and observation, decoding the truth through speed, light, and silence. The story of Oumuamua is not just built on speculation. It's rooted in a growing body of measurable, repeatable, and fascinating data. From its speed and mass to its unique acceleration pattern and spectral analysis, Oumuamua continues to defy easy explanation. And now that it has returned, the new round of observations only deepens the mystery. By diving into what the numbers actually tell us, we begin to understand why this object refuses to fit any known category and why scientists around the globe are watching it more closely than ever. When it was first detected in 2017, Oumuamua was already moving at a staggering speed, approximately 315,000 kilometers per hour. That's over 87 kilometers per second. At this velocity, it was clear to astronomers that the object wasn't bound to the sun like traditional comets or asteroids. It was on a hyperbolic trajectory, one that confirmed its status as an interstellar object. This was not something from within our solar system. It was the first object of its kind, the first confirmed interstellar visitor to enter and exit our celestial neighborhood. What set Oumuamua apart wasn't just its speed, but the strange way it moved. As it traveled past the sun, astronomers expected it to follow a path shaped solely by gravitational forces. Instead, it began to accelerate, ever so slightly, but detectably. The acceleration wasn't dramatic, but it was consistent enough to raise alarms. There was no visible exhaust, no jetting of gas or debris that might suggest comet-like activity. This non-gravitational acceleration puzzled scientists. In normal space physics, an object either speeds up due to external forces or slows down. Oumuamua seemed to generate its own momentum. New observations in 2025 show that this pattern hasn't changed. In fact, the current data suggests a similar if not slightly more complex trajectory. When comparing its previous motion to its new path, astronomers have found that Oumuamua once again displays a subtle acceleration that can't be explained by gravity alone. What's more intriguing is that the companion objects discovered alongside it exhibit similarly inexplicable behavior. The coordinated movement further complicates the narrative, reinforcing the idea that something else may be influencing their paths. One of the most important tools for analyzing celestial objects is light reflection. By studying how sunlight reflects off an object's surface, scientists can estimate its shape, spin, and even surface composition. In Oumuamua's case, the light curve revealed that it was tumbling end over end every 7.3 hours. This irregular rotation was not only uncommon but suggested a shape that was at least 10 times longer than it was wide, something that had never been seen before. These new readings in 2025 confirm the tumbling motion, but slight deviations in the light curve hint at surface changes or external interactions. Whether it's due to aging, erosion, or interference from its companions is still under investigation. Spectral analysis remains one of the most powerful ways to understand an object's composition. Scientists pass the light reflected off an object through spectrometers to identify the specific wavelengths absorbed and reflected. These wavelengths act like fingerprints, revealing the materials present. In 2017, Oumuamua's spectrum showed no signs of water, gas, or carbon-based compounds typical of comets. It was unusually neutral, further fueling the alien probe theory. The updated spectral scans from 2025 reinforce this enigma. Once again, no water, no gases, no organic signatures, just a flat spectrum with minor fluctuations that researchers can't yet match to any known material. Equally baffling is the radio silence. SETI has scanned Oumuamua repeatedly for electromagnetic signals, using powerful radio telescopes tuned to frequencies typically associated with intelligent communication. In 2017, they heard nothing. In 2025, with more sensitive equipment and real-time tracking capabilities, they're still hearing nothing. While this doesn't rule out artificial origin, it does challenge the idea of Oumuamua as an active transmitter. If it is a probe, it may be passive, observational, or even long since abandoned. To put this data into perspective, it's helpful to compare Oumuamua with another interstellar object, Comet 2I, Borisov. Discovered in 2019, Borisov was only the second confirmed interstellar object. Unlike Oumuamua, Borisov behaved much like a traditional comet. It had a clearly visible coma, expelled gas and dust, and followed a predictable gravitational path. Its spectral profile matched known cometary materials. Borisov was fast, but not mysterious. It came and went like an ordinary traveler from another star. The contrast with Oumuamua is stark. Where Borisov was explainable, Oumuamua is defined. Where Borisov confirmed what we already knew, Oumuamua forced us to question everything. Space object tracking has become a key area of focus in the wake of Oumuamua's return. Algorithms are now continuously modeling its path, scanning for any deviations, accelerations, or course corrections. These models are based on billions of data points from satellites, observatories, and space agencies. So far, every anomaly, every unexplained shift in direction is being catalogued and analyzed. And while no clear signal or propulsion method has been identified, the consistency of the object's odd behavior over two separate visits adds serious weight to the hypothesis that this is no random space rock. Some scientists suggest that Oumuamua may represent a class of objects we have never encountered before, fast, tumbling, non-emissive interstellar visitors that defy the traditional labels of asteroid or comet. Others remain focused on the possibility of technological origin. But all agree on one point: the data does not align with anything we currently understand. The numbers don't lie. Oumuamua's velocity, its shape, its acceleration pattern, its spectral neutrality, and its silence all stand out as statistical outliers in the known database of space objects. And now, with similar behavior observed in its companion objects, the anomaly is no longer singular. It's a pattern. A disturbing, fascinating, and possibly revolutionary pattern. Oumuamua may not be telling us everything we want to know. But through its movement, its silence, and its resistance to natural explanation, it's revealing something even more powerful: how much we still don't know about our own cosmic backyard. And perhaps, how much more there is waiting to be discovered. NASA's latest involvement and future mission, tracking the untrackable and planning for what comes next. Since the confirmation of Oumuamua's return in 2025, NASA has significantly ramped up its observation efforts. This isn't just a fascinating space object anymore, it's a high-priority anomaly. Oumuamua, once an elusive interstellar visitor, has now re-entered the solar system accompanied by several mysterious companion objects. The unusual behavior and unexplained characteristics of these objects have pushed the agency to assign more resources, more time, and more scrutiny to what is now considered one of the most compelling cosmic puzzles of the century. NASA's primary observation initiative is centered around its Deep Space Network, a global system of powerful radio antennas designed to communicate with distant spacecraft and monitor deep space phenomena. Oumuamua tracking is now being conducted around the clock, not only by these massive radio telescopes but also through space-based assets like the Hubble Space Telescope and the James Webb Space Telescope. These instruments are capturing high-resolution imagery, conducting spectral analysis, and collecting light curve data from the primary object and its companions. The goal is to understand what these objects are made of, how they move, and why they refuse to follow conventional expectations. The Jet Propulsion Laboratory in Pasadena has also devoted a team of astrophysicists and engineers to model Oumuamua's potential origins and destinations. Real-time simulations are running around the clock, feeding data from NASA's planetary defense systems and observatories across 6 continents. In the past, these teams focused on tracking asteroids that might collide with Earth. Now, they're applying those same tools to study an object that seems to defy the natural order, an interstellar probe, perhaps, or something else entirely. But despite all this attention, one of the biggest challenges remains unchanged. Intercepting Oumuamua is incredibly difficult. The object is still moving at interstellar speeds, well over 87 kilometers per second. Its trajectory, while now more predictable thanks to continuous tracking, is still angled in such a way that no existing spacecraft can catch up in time without an enormous amount of fuel or new propulsion technology. The angle of approach, relative to Earth's orbital position, makes it virtually impossible to launch a mission quickly enough to reach it during this current pass. That hasn't stopped NASA from planning ahead. One proposed concept, known as the Interstellar Probe, was originally intended to exit the solar system and explore the heliopause. Now, that mission concept is being modified with new goals in mind. Scientists are evaluating whether it could be adapted to intercept future objects like Oumuamua. A new class of high-speed probes, possibly powered by solar sails or nuclear propulsion, is under early-stage development. These technologies could one day make it feasible to match velocities with fast-moving interstellar visitors. If not this one, then perhaps the next. NASA isn't alone in its efforts. The European Space Agency has launched a collaborative initiative with leading universities and aerospace contractors to design a robotic interceptor that could reach similar objects if given early warning. Their plan involves a rapid launch system that could be deployed within months of detection. While still in conceptual stages, funding has increased dramatically since Oumuamua's 2025 return. China's National Space Administration has also shown interest. Officials there have hinted at plans to develop a long-range space probe capable of traveling beyond the Kuiper Belt. Though specific missions haven't been announced publicly, Chinese astronomers are closely monitoring Oumuamua's trajectory and contributing data to international research groups. Private space companies have also joined the conversation. Some are proposing flexible, modular spacecraft that could be configured and launched on short notice. These platforms, driven by AI-guided navigation systems, could potentially rendezvous with fast-moving interstellar objects. While ambitious, these ideas are drawing investor interest, particularly from those who believe humanity is on the cusp of a new era in deep space exploration. In the end, tracking Oumuamua is only half the battle. Understanding it, up close, in real time, will require a breakthrough in propulsion, coordination, and readiness. As of now, no nation or organization is capable of launching a mission fast enough to reach it during this current visit. But plans are evolving. Technologies are advancing. And the collective will to meet Oumuamua on its terms is stronger than ever. Whether or not we can intercept this object, NASA's commitment to unraveling its mystery is clear. With new data arriving daily and global cooperation intensifying, the groundwork is being laid for a new generation of missions. Missions not just to explore, but to historical and cultural parallels. Long before telescopes, satellites, or spacecraft, humans have looked to the sky and wondered what lies beyond. The strange reappearance of Oumuamua and its unexplained companions taps into a very old instinct, one that has shaped myths, inspired religions, and fueled thousands of years of storytelling. Across every continent and culture, records of strange lights, fast-moving stars, and unexplained celestial objects have been passed down for generations. The idea of star messengers is not new. It's as old as civilization itself. In ancient Mesopotamia, Sumerian texts describe the Anunnaki, beings who arrived from the heavens, often associated with fiery stars and traveling lights. In Mesoamerican cultures, the Mayans recorded appearances of sky serpents, celestial bodies they believed carried messages from the gods. Aboriginal Australians spoke of the Wandjina, sky beings connected to weather and creation. Even in ancient China, astronomers documented events that could be interpreted as early UFO sightings or interstellar phenomena, often linking them to political upheaval or divine messages. These weren't simple fables. They were interpretations of real experiences, filtered through the language and understanding of the time. What stands out across these ancient alien sightings is the recurring theme of visitors, messengers not of this world, arriving to observe, teach, or judge. These stories were often deeply spiritual, yet they always revolved around an encounter. In every case, the unknown object from the sky was assigned meaning. In some stories, it brought wisdom. In others, destruction. But the pattern is clear: when something unexplained appeared in the sky, it was never ignored. It was integrated into the culture's most sacred narratives. Modern science often dismisses these stories as allegory or misinterpreted natural events. Yet in light of Oumuamua's return and the increasing possibility of genuine interstellar contact, many are beginning to look at these ancient myths with fresh eyes. Could early civilizations have witnessed events similar to what we're seeing now? Were they trying to describe, in the language available to them, an encounter with something not of this earth? Beyond the cultural narratives lies another important question. How do humans interpret the unknown when it comes from the sky? Historically, we tend to oscillate between awe and fear. The arrival of a comet, for example, was long considered a bad omen. Eclipses were seen as cosmic battles or warnings from the gods. Even today, a mysterious signal from space can ignite conspiracy theories, religious revivalism, or calls for scientific breakthrough. The cultural reaction to space phenomena has always been a mix of curiosity, reverence, and deep existential questioning. This brings us to a modern concern. With Oumuamua's return and the possibility that it could be artificial, or even intelligent, are we psychologically prepared for a real first contact? The truth is, probably not. Despite decades of science fiction and theoretical frameworks, the sudden confirmation of intelligent life would likely cause massive disruption. It would challenge religious beliefs, social hierarchies, political systems, and even our scientific understanding of reality. The first contact psychology that governments and scientists study often warns of widespread confusion, fear, and even panic, especially if the nature of the contact is unclear or perceived as threatening. That's not to say we are doomed to chaos. Human beings are also remarkably adaptable. Just as ancient cultures integrated unexplained sky events into their belief systems, modern society may eventually evolve to accommodate a new cosmic reality. But the initial reaction is important to anticipate. That's why institutions like NASA and the United Nations have quietly developed protocols for disclosure and global communication in the event of confirmed contact. These protocols focus on transparency, containment of misinformation, and gradual dissemination of information to avoid societal shock. Oumuamua's return with a possible fleet may not yet constitute direct contact. But it is pushing us closer to that threshold. Whether it turns out to be natural or artificial, the mere possibility is enough to stir deep human instincts, instincts that have always looked upward for meaning, for connection, and for answers. This is no longer just about space. It's about the human condition. About how we, as a species, respond to the unknown. and about whether the stories of the past might contain echoes of the future we're about to face. Expert opinions and controversial takes. Scientists, insiders, and the great divide over what Oumuamua really is. As Oumuamua returns in 2025 with a fleet of mysterious companion objects, the conversation around its origin has reignited across the global scientific community. But this isn't a simple case of agreement or consensus. In fact, the divide between experts has only widened, giving rise to one of the most heated debates in the history of space exploration. From Harvard professors to SETI researchers and aerospace insiders, everyone has a theory, but not everyone sees the same thing when they look at Oumuamua. Harvard astrophysicist Avi Loeb remains one of the most vocal proponents of the alien origin theory. Known for his willingness to challenge convention, Loeb insists that Oumuamua's shape, acceleration, and now, its accompanying objects, are better explained by artificial design than by natural causes. In a recent televised interview, he stated, "Nature doesn't make fleets. The presence of multiple objects moving in formation with consistent velocity, and without any gravitational binding, suggests coordination. And coordination implies intent." This single quote sent shockwaves through both academic circles and the public imagination, instantly trending under the phrase, Oumuamua expert opinion. But not everyone shares Loeb's perspective. Within SETI, the search for extraterrestrial intelligence, researchers are cautious. While the organization exists to find signs of alien life, its scientists often emphasize the importance of extraordinary evidence. Dr. Jill Tarter, one of SETI's pioneers, recently commented that while Oumuamua is absolutely anomalous, calling it artificial without hard data is premature. She added, "The absence of emissions or signals doesn't prove technology. It just proves that we're still in the dark." NASA scientists have echoed similar sentiments. In internal briefings released to the public, they acknowledge that Oumuamua's behavior is outside standard models but stress the need for restraint. A recent white paper authored by a panel of NASA astrophysicists noted that, until further observation yields testable hypotheses, Oumuamua remains an unidentified interstellar object. The term, unidentified, is deliberate, chosen specifically to avoid the implications associated with the more loaded term, extraterrestrial. Meanwhile, voices from within the aerospace industry are adding new dimensions to the discussion. Engineers and mission planners who deal with spacecraft design have begun examining the implications of Oumuamua's motion. A former propulsion expert from SpaceX, speaking anonymously, claimed that the object's trajectory shifts resemble low-energy course corrections used in interstellar navigation simulations. He noted, "The object doesn't move like it's just coasting. It moves like it's making choices." This idea has found support in unexpected places. A group of independent researchers working in collaboration with European observatories published a paper proposing that the observed behavior of the object and its companions fits known models of swarm robotics, a concept used in modern drone technology where small units coordinate through simple rules to create complex, adaptive behavior. The implication, though purely hypothetical, is chilling. What if Oumuamua's fleet is not a collection of probes but an autonomous, distributed system sent to gather and analyze data across wide areas of space? On the other side of the spectrum, critics of the alien origin theory warn against what they call cosmic sensationalism. Astrophysicist Dr. Ethan Siegel argues that Oumuamua is simply revealing the limits of our understanding, not the presence of extraterrestrial life. He stated in a recent article, "When something doesn't fit our models, the answer isn't always aliens. Sometimes, it's that our models are incomplete." The debate is further fueled by the lack of definitive evidence. The current observational data points to anomalies, non-gravitational acceleration, unexplainable formation movement, absence of emissions, but none of it conclusively proves intelligent design. And that gap between observation and conclusion is where much of the controversy lives. Public interest has only intensified the divide. With millions following the story and social media amplifying every expert quote, the pressure on institutions to take a definitive stance has grown. Yet, most scientists and officials remain cautious, choosing measured language and conditional phrasing over dramatic claims. The SETI alien life debate has entered the mainstream, and with it comes the risk of misinterpretation, misrepresentation, and misinformation. Still, there is a growing sense that something unique is unfolding. Whether Oumuamua turns out to be a cosmic fluke or the first known artifact from another civilization, the way experts engage with this phenomenon marks a turning point in how humanity confronts the unknown. No longer is space exploration debate confined to dusty labs or academic journals. It's happening on news networks, in podcasts, and across live streams, places where scientific authority meets public curiosity. As the object continues its journey, the world waits not just for more data, but for clarity. Clarity that might come from further observation, from a closer mission, or from a future event that finally provides the missing piece. Until then, Oumuamua remains the center of a storm where evidence, theory, and belief collide. What if it's an alien probe? Realistic scenario exploring the possibility of technology beyond Earth. If Oumuamua is more than a space rock, if it is, in fact, some form of alien probe, what does that mean for humanity? The alien probe theory, once a fringe idea, has taken on a new life since Oumuamua's return in 2025. With its mysterious acceleration, unusual shape, and now the addition of multiple synchronized companion objects, the idea that we might be witnessing an intentional, technological presence has moved from pure science fiction into serious scientific consideration. When people hear the phrase, alien life, most immediately think of humanoid creatures or biological beings. But the more likely first contact scenario may not involve living entities at all. It could involve machines, drones, scouts, or self-replicating probes sent by an intelligent species from a distant star system. If we consider the vast distances between stars, sending biological life across interstellar space becomes incredibly inefficient. Machines, on the other hand, can travel for thousands of years, withstand radiation, and remain operational far longer than any organic life form. This makes a strong case that if extraterrestrial intelligence has visited us, it likely did so through artificial means. The idea of a probe, perhaps a scout vessel designed to survey, record, and report, aligns well with what Oumuamua appears to be doing. Its speed and path suggest it wasn't just drifting aimlessly. Its return, along with other objects in formation, may represent a second phase of a broader exploratory mission. Some researchers propose that these could be autonomous drones programmed to explore promising planetary systems. If they detect signs of technology or biology, they may relay that data back to their origin or await further instructions. Others believe we could be observing a von Neumann probe, a self-replicating machine designed to create copies of itself using available materials, spreading across the galaxy over millennia. If this is true, the implications are staggering. The existence of such a probe would confirm the presence of life beyond Earth. More than that, it would suggest that the intelligent life that created it is significantly more advanced than we are. This touches the very core of our understanding of the universe and our place in it. The alien probe theory challenges long-held assumptions about technological development, survival, and communication across vast cosmic distances. From a scientific perspective, such a discovery would trigger an explosion of new fields and funding. Astrobiology would become the most urgent discipline in science. Engineers would begin studying the probe's potential structure and function, reverse engineering any detectable technologies. Governments and private firms would race to be the first to make contact, unlock secrets, or gain access to advanced knowledge. But the consequences wouldn't stop at science. Religion and philosophy would face enormous questions. The belief systems that have guided humanity for millennia might be shaken, or perhaps, for some, validated. Were these the messengers described in ancient texts? Are we part of a broader cosmic plan? Or merely one of many species being observed from afar? Society as a whole would also change. Some would react with fear, others with awe. There would be debates over how to respond, whether to send a signal, or whether silence is safer. International alliances might form to create a unified global policy. Conversely, old rivalries could intensify if the object is perceived as a threat or opportunity. The presence of extraterrestrial intelligence would not only rewrite textbooks, it would reshape geopolitics, economics, and even daily life. For now, Oumuamua remains silent. No message, no signal, no overt action. But its return with a fleet of companions, and its continued resistance to natural classification, makes one thing undeniable. The door to the question of life beyond Earth is now wide open. And if what we're observing is a probe, a scout, or a sentinel, then we are no longer just observers of the cosmos. We are participants in a conversation that began long before we knew we were listening. What happens next? The timeline and watch list tracking the mystery as it unfolds in real time. With Oumuamua once again in our solar system and accompanied by enigmatic companion objects, the focus has now shifted from speculation to continuous monitoring. Scientists around the world are actively charting the object's every move, and the months ahead promise to deliver the most detailed data we've ever had on an interstellar visitor. The big question is, what happens next? The next major observation windows are unfolding as Oumuamua moves closer to its nearest point to Earth in its 2025 return. During this time, its position relative to the Sun and Earth allows for more precise tracking using optical and infrared telescopes. NASA has scheduled peak tracking sessions using both the James Webb Space Telescope and ground-based instruments like the Keck Observatory in Hawaii. These sessions will be crucial for updating the Oumuamua tracker used by astronomers and researchers, enabling them to refine models of its movement and determine whether its acceleration continues to defy explanation. Scientists are watching for very specific events. They're hoping for more rotational data to help confirm whether Oumuamua's shape has changed since 2017. They're analyzing the timing and spacing of the companion objects, trying to detect any shifts in formation. If any deviations in trajectory, flickers in reflected light, or unexpected radio signals occur, those will instantly become top priorities for investigation. The scientific community is particularly alert for any signs of interaction, either between the objects themselves or with our observational instruments. For the public, this is a rare opportunity to follow a space phenomenon in real time. NASA and several observatories have set up online portals that provide daily updates, live tracking maps, and visualization tools. YouTube channels and space news updates now regularly include Oumuamua's latest location and velocity, making it easier than ever to stay informed. The keyword, Oumuamua tracker, has become one of the most searched phrases in space-related news. As Oumuamua continues its journey through the inner solar system, everyone is watching, scientists, skeptics, and curious minds alike. Whether the next discovery is a breakthrough or another mystery, this moment represents a milestone in humanity's effort to understand the unknown. And it's far from over. Are we alone after all? The deeper meaning of Oumuamua and the future it points to. Oumuamua has always been more than just an object passing through the night sky. From its first appearance in 2017 to its shocking return in 2025, it has remained a persistent enigma. Its unnatural acceleration, its lack of visible propulsion, its elongated shape, and now the presence of mysterious companion objects have pushed the boundaries of what we thought was possible. These are not the characteristics of a typical space rock. They are pieces of a puzzle that continues to grow more complex with every new observation. The facts are clear. Oumuamua is not behaving like any comet or asteroid we've seen before. It doesn't emit gases, it doesn't follow predictable paths, and it doesn't come alone. The latest data shows it is being trailed by several objects in formation, all of which seem to defy the laws that govern most celestial bodies. The scientific world remains cautious, but even the most conservative voices now admit that this situation is unlike anything previously recorded. The meaning of Oumuamua may not yet be fully known, but it is already rewriting the way we explore and think about space. And so we return to the question that has haunted astronomers, philosophers, and dreamers for generations: are we alone? Oumuamua doesn't answer that question directly, but it forces us to confront it with greater urgency. If this is not alien life, it might still be a signpost, an artifact left behind by something or someone far more advanced than us. If this is nature, it's a type of nature we've never encountered before. Either way, the implications are profound. The search for alien life in 2025 is no longer confined to radio signals or distant exoplanets. It's now happening in real time, in our own cosmic backyard. Oumuamua is not just a visitor. It's a reminder. A whisper from the stars that the universe is still full of secrets, still ready to surprise us. So what do we do next? We keep watching. We keep asking questions. We keep pushing the limits of what we know. Because if there's one thing Oumuamua has taught us, it's that the unknown is closer than we think.